First of all, thank you for having me. And before I start with the technical stuff, I'll first introduce myself. So I'm Chato from Belgium. I'm 26 years old, and the computer is not working. So, and I started programming when I was 13. Basically, I was playing a game called Minecraft. So I started programming when I was 13. I was playing on a game called Minecraft. And apparently, you can add custom experience there by coding. So I tried to figure out how it works, and I was looking for videos on YouTube and learning how to code in Java. So after that, I was gaming and programming and learning everything. And I started my first company when I was 17, just a simple software company where we built software for other people and for ourselves. The coolest thing we made there is a simple application for your phone where you could control your entire computer. You could make screenshots, you could send commands, you could do whatever you want just based on an app. And with this, we also got into local TV and radio. And then we all started going to study college, university, so that project fell apart a bit. But my hunger for like programming and building companies was still there, so I tried several stuff. One of them was a physical hardware device where you could analyze your golf swing, or other projects like analyzing medical health data for people who doesn't understand health stuff. So I was trying a lot of different projects and raising a bit of funding, but none of them really stick there. So I was just building software basically, and then I decided 2 years ago to start a software boutique with 2 other friends. What is this? It's basically a software agency where we try to build the best of the high-end software there is without compromise. So we are focusing on quality and testing everything around this. And based off that, last year I sold my shares to just 2 other companies because it was fun, but it grew a bit too much for me, and I was trying to explore different software principles and stuff. So from the software boutique, I learned a lot of stuff about building the best product there is in software. And one of the main takeaways is like how to build a really future-proof software. With future-proof, I mean it's like it's software that's still relevant and working and easy to maintain in 10, 15 years. First, you might think it's something that sounds impossible, which isn't if you really dig into it. There are like a few aspects within the development cycle you can tackle and ask questions to like make sure okay every aspect is there and everything you do will be later on very good and still be usable. So the main things I will be talking about today is like the choice of languages and frameworks you use, architecture, databases, and the DevOps setup you have. So first of all, there's one question we need to remember when we try to solve everything, and it's how will the future look like and what will we do, what do we need? That's not important yet. So the reason behind this question is because good software teams work with the agile method, and so they usually work in different sprints, and within their sprint they focus on the features they have to do. But usually when you do this, you forget about the bigger picture and you just try to focus on, okay, we have to build this feature or this solution, and we will do whatever it needs to achieve this. But by doing this, we will lose a lot of context and information later on, where we need to rewrite everything later on. So we try to look always at like, okay, what's the final goal we try to achieve, and how can we make sure that goal is still easily achievable when we work on this sprint, when we work on these features. So the first choice we have to make when we start a new project is our choice of programming language or framework. Usually you can think like, okay, we'll just use what we know the best because that's the easiest solution, and if everything is right, it will be okay. But often that's not the right choice if you don't think it through. So important there is you have to think critically and you have to ask a lot of questions on how to do this. And you might be wondering like which questions do you ask and how to achieve the best solution. So I've written down a few questions you could ask. One of them is like, okay, I want to use this programming language. Is this still relevant and still updated regularly? Because there are a lot of developers, mainly senior developers, who still use a lot of older languages and think, okay, if you use this, it will be fine because I've been using this for the past 15 years. But actually, it's important to keep challenging yourself when trying to develop. Also, one of the most important questions and underlooked questions like, is this programming language or framework you're using, is this like used or taught in school, colleges and stuff? Because we want to hire later on people that can work for us, but if we cannot find these people and we need to educate themselves, it will take more time and more resources to get the best team there is. So we try to look at a language that's like popular and being taught in the schools already. Also, nowadays, you can basically use every programming language for every use case. You can build an entire AI system in JavaScript, or you could build your entire front-end in Python. But both of those cases are not really the best ones. So it's the challenge that, okay, of this programming language, how can I make sure the programming language is actually made for my use case? And also something very often is like all the functionalities I have now I want to implement later on. Can I do this with my one programming language? Because people often forget that they can just split up their entire project in chunks and use different programming languages and different frameworks for different features they want to achieve. So those are like baseline questions you can use to make sure our choices are correct. But most important is our first question ahead, like how can we, what will the future look like and what do we not know yet? We cannot forget about this while looking at the other questions. So then, the other choices you have, like for architecture, we have two main choices, monolithic and microservices. So for you guys who don't know what a monolithic service is, like it's one single low code base, easy and quick to develop and maintain, but usually hard to scale since it's one big service you're running. For microservices, it's all separated, different chunks, they're communicating to each other through APIs. It's in the beginning hard to set up, but once you got it, it's fine, and then very scalable. So both of them, you have a choice to pick. Usually then a microservice is the way to go when you scale your application. But what I found out, like often when you try to implement a microservice architecture, it's often done wrongly and it's just a monolithic service, just disguised as like vendor layer of microservices. So it's important to maintain and to look at your code base to make sure you're using the right practices and make sure the implementation is correct. And of course, our question, you cannot forget about it when choosing what to do. So our next choice is our databases. Here you can think, okay, you just pick one and see what happens. But the tricky part with databases is that whenever you've chosen one and you've already used it, migrating it to another database will be very painful and not very fun. So that's why I want to make sure the setup of the database is correct and we have used the correct option, because nowadays you have a lot of different options, but we have a few questions we need to answer first. Like for example, how will our data change over time? Are we 100% sure that data we have is fixed and has a fixed format, or will it change, will it grow based on time, based on usage? Also, how frequent we need data, depending on like if it's more cold storage data or like hot data, which data provider or database provider will be best for a use case. Also, how and what data will we access? is important to know since indexing and other stuff around databases there is depending on what you choose. So we have these basic questions, but could also look back at the questions of our programming languages. You need one fixed database, or can we like split up different functionalities into different databases to make sure we are using like the best tool and the best performance for what we are trying to do. So it's basically trying to push with these questions to think out of the box and making sure like, okay, what we choose, it will stay here for at least 10, 15 years, will it be still relevant and good choice by then. So, and also we can talk about our biggest question, what will the future bring us? And then our last choice we have to make is DevOps. Usually people don't care about this because nobody knows how it works, but it's important to make sure you ask the right questions there as well. Definitely when it comes to cloud infrastructure and what kind of services we want to use. Also for the pipelines of deployment and how we document our development environment and infrastructure. There are still a lot of options, but with these questions we can filter all the options and just pick the one we need. And a funny thing I had with the clients, so the clients gave us a project where they developed a pipeline took hours to run. And the reason because of this is people were like over engineering their pipeline and we just rebuild everything and simplify it. And for the same code base and project, we moved the deployment from hours to 3 minutes just because they were like trying to be fancy and to make sure, okay, if you want to do this in the future, we can still do this. But if we can do it, those things they wanted to try to keep available were not needed and will never be needed. So, and our biggest question, kind of that. So to recap, there are a few things I will say again, and then I have 2 examples around this. So the question then we have to remember is like, okay, what will we do in the future? How will we do this? And what do we still need in the future? It's just very important to remember and to grab back to it when we are building and choosing the components of our product. Also, when choosing, just weigh out the pros and cons of everything what we're doing because we have tons of options for every aspect in our project, but not all options are good and not all options are optimized and performing for what we are trying to do. And just basically choosing the best tool for the job. When we, for example, try to hammer in a nail, we don't use a banana but a hammer. So you can look at it this way. Also, just don't be afraid to think outside the box because a lot of people recommend a lot of stuff, but it's too much to think about it. You can just think, okay, people do it like this, but if we need in another way, or can we just do something crazy or split up different stuff so we have the best things for every aspect in our program. So, for example, so we had one client who just said to us, like, we want to have our users synchronized from one location to another location, but our company is eco-friendly, so everything we do needs to be energy efficient, good for the environment, and knowing how to do the software is usually not environmentally friendly. So we try to figure out a way how to make sure, like, what we build is using the minimal amount of energy needed and we don't do overcomplicated actions. So what we did is we chose a programming language that's efficient they use. We used Golang. It's one of the most efficient programming languages when you run it compared to Python or JavaScript. Also, instead of using a server that's running 24/7, we use a smart system with serverless functions, where we only have to run for the milliseconds we need to run it for. So the energy usage is really minimal compared to original implementations and other stuff is needed. And to make sure everything is eco-friendly, we also added a monitoring system for energy consumption, just to make sure if you run it, how much energy do we use, and compare it to alternative solutions on the market, you're like 200% cheaper in energy. So that's a thing we try to solve. And the last example I have is from Facebook. So Facebook is trying to build the best spam filter there is. First, they use their own language they made themselves, FXL. But the language they made had some performance issues, and they wanted to get their team focused more on building the spam filters instead of optimizing the code. So they looked at like the programming languages that already exist, and they found Haskell. Haskell is a functional programming language which focuses on just rule sets and making sure like if you have a case, it's the only case possible. So whatever you write, it will happen or it won't happen. So this way you could just focus on the performance instead of you could just focus on your spam filters instead of the performance. So they choose to migrate their entire code base to Haskell to make sure their spam filters are better and more performant. So to finish up this keynote talk, you can only on LinkedIn if you want, and thank you for listening.